Black holes, guys, they're back. We can't get rid of them because, well, they're slowly gobbling up our entire universe, exponentially getting more and more prevalent as the eternal cosmic dial slowly ticks back to infinity. The fact of the matter is, though, black holes have consistently been the proverbial thorn in the side of physics for centuries, a cosmic entity that has constantly pushed the boundaries of what we know about the universe. And on the grand scale of things, we don't know much for certain, but theoretically, we do know that there's a boatload of cool stuff just waiting for us on the horizon. So, in that case, let's take a look, shall we? Hello Internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied flowing voice, Jack Finch, as today we curiously ask the question, can we harvest energy from a black hole? Roll the clip. Don't worry guys, it wouldn't be anywhere as near as devastating as that, mainly for the fact that whatever black hole technology our advanced civilization managed to muster, we'd never be foolish enough to press the big red on button whilst on planet level, right? For the curious amongst you, that clip was from 2009's Star Trek, directed by J.J. Abrams, and it's a pretty fitting choice for our opening clip. As for our hypothetical advanced civilization to have the means to harvest the energy of a black hole, we'd probably already resemble the awesome United Federation of Planets, which is something to look forward to, I guess. Now, for those of you that have already seen our previous black hole video, What If You Grew Up at the Edge of a Black Hole, we briefly outlined the mechanics of a civilization hundreds of thousands of years in the future, and the means of technology that they'd have to employ to survive in the literal dark age of the universe, when all the stars were burned out and only supermassive black holes remained. So if you haven't seen it, now would be high time to head on over and check it out, because in this video we're sinking our teeth into some of the most theoretical of theoretical physics going. So let's boil it down. Can we harvest energy from a black hole? Well, the quick answer to this question is hell yes we can, and not only is it possible, but it's theoretically speaking one of the most efficient energy sources in the known universe. However, it's in the implications of an advanced enough civilization capable of this method of energy conversion where things get really interesting. And for the most part, the fun of this question is how we can speculate on exactly what our spacefaring species would look like. Imagine thousands of years in the distant future, perhaps even hundreds of thousands of years, where humanity has evolved past the point of theoretical physics into the realm of practical science and technology, utilizing the same methods that were once scrawled on chalkboards by grumpy old professors thousands of years before. That's if the current scientific model is correct anyway, but that's by the by. At that point in space and time, it would be safe to assume that our species were entirely capable of efficiently traversing the universe to begin harvesting the energy from a black hole. Because as it stands, with our current levels of technology, even getting close to the nearest black hole would probably take roughly 12 million years. And as we know, time is money, friends. For the sake of brevity, let's just circumvent that entirely and assume that some kind of revolutionary warp drive or antimatter propulsion engine has already been discovered to further our civilization's method of harnessing the incredibly potent energy of a black hole. If the scientific model's current understanding of astrophysics and general relativity is correct, then our distant descendants would most likely employ what is known as the Penrose process to squeeze out the theoretical juice. As the name suggests, this idea was first hypothesized by our man Roger Penrose back in 1971, who coincidentally was best buds with the late great Stephen Hawking, and the two of them conjured up all kinds of awesome ideas about the physical magnitude of the cosmos. Great guys. In essence, we've known for a while that almost every black hole rotates at an absolutely staggering speed, and this same effect pulls any material approaching it into what's known as an accretion disk, kind of like that stuff you see in the rings of Saturn. And like with most things, the fun stuff starts when you begin throwing junk at it. Essentially, black holes are kind of like giant plug holes, but not in the conventional sense, because as the matter of the accretion disk spirals inward, exponentially moving faster and faster, wrapping more and more tightly around itself, and before it completes its descent, it will start feeling an intense, unimaginable friction. In essence, it will give itself a carpet burn on a cosmic scale. And as we know, any kind of friction yields energy. We are talking radiation on an extragalactic scale, the mass of the accretion disk directly transmuted into X-ray energy. For For a scale of reference, our current best method of converting matter to energy, nuclear fission, roughly has an efficiency conversion of 0.1%. On the next rung of the ladder, the sun's process of nuclear fusion is far, far superior, yet only converts 0.7% of its hydrogen mass into light energy. The other 99.3% is lost as helium. Black holes alone, all by themselves, just doing what they're doing, gobbling up space, time and matter, have an energy conversion rate of perhaps up to 40%. 40%, that is staggering. A single kilogram of matter converted 40% of the weight into energy would yield roughly 36 petajoules or 10 terawatt hours of energy. That's enough to power our entire planet for half an hour with a single kilogram of matter. We just need to find a way to harness that energy without slipping down into the void, because that's the real problem, right? Black holes are dangerous, and any kind of black hole workers union would have their work cut out for them, to say the least. But the Penrose process goes one step further and notes that the rotational energy of a black hole isn't located inside the event horizon, but instead on the outside of it, in a region referred to as the ergosphere. This is where things get a little bit weird, and Penrose theorizes that any carefully arranged object of matter on this plane could theoretically rotate in space-time for infinity. Its momentum juxtaposed between greater mass energy and negative mass energy. Now, if say that object was a mirror and we arranged the structure of massive reflective surfaces in the black hole's ergosphere, we could theoretically shoot a beam of light into the black hole, and our civilization could subsequently harvest the super energetic light as an infinite source of free energy on an unimaginable scale. Obviously, the cost of such an endeavor would be astronomical at first, but it would pay dividends for literally infinity. And in terms of energy efficiency, there is no better deal in the known universe than that of a black hole. Hey, I'm starting to sound like some kind of black hole energy salesman, aren't I? Well, in that case, theoretically speaking, there's a whole new industry just waiting to be discovered. Isn't the universe awesome? Well, there we have it, our answer to the eternal question: can we harvest energy from a black hole? Yes, on paper anyway, but the logistics of such an operation are still pending the approval of the entire human species. Hurry up guys, there's so much stuff out there. So what do you guys think? Do you have a better way to harvest the rotational energy of a black hole than Roger Penrose himself? Let us know your master plan in the comment section down below. Before we depart from today's video, let's take a quick look at some of your more resounding remarks from over the past few days. AJ Neve says, I wish Jack Finch would read this comment. Sad face. Don't worry AJ, I got you bud. Hopefully that sad face is now a happy face. On that note, unfortunately that's all we've got time for in today's video. Cheers for sticking around all the way until the end. If you were a fan of this video or just LBQ in general, then please be a dear and hit that thumbs up button as well as that subscribe button, and I'll be seeing you in the next one. As per usual, I've been your disembodied floating voice Jack Finch. You've been watching Life's Biggest Questions, and until next time, you take it easy.